So this is just part 2. I just stopped it just because it was so long, not because this is a new kind of problem. And maybe let's do 19 together because it's a part A and a part B. Probably means I need a parentheses in one of the parts. So if I look at 19A, which maybe you can pause the video and try to do it, it starts off saying twice. And twice is a word that tells me it's going to be 2 times something. And what I'm multiplying by is the sum. I'm not multiplying by Mark's age. I'm multiplying by the sum of Mark's and Paul's age. So what I need to do first, before I do the multiplication, is I need to find the sum of Mark's age and Paul's age. And I don't even have the sum in here because I was cutting and pasting, obviously not paying a lot of attention. Sum is an adding and you keep the order. So the sum of Mark's and Paul's age using the variables that were given, capital M for Mark's age, capital P for Paul's age. The sum of Mark's and Paul's age is just going to be M plus P. Sum is adding and keep the order. Now I want to find twice the sum. For my answer, because I have to multiply by the entire sum and not just by Mark's age, I'm going to need a parentheses. The times sign becomes not necessary because the 2 next to the parentheses, there's an implied times there. So I got sneaky here and I made the parentheses the part A, which is, just so you're not thinking, well, every time if there's an A and a B, the A is a parentheses and the B isn't. For part B of number 19, first I'm going to find twice Mark's age. So you see the difference here. Here in problem 19A, I'm finding twice the sum, not finding twice Mark's age. Here in part B, I'm finding twice Mark's age. Twice means to multiply by 2, and the variable for Mark's age is the letter M. Next thing I see is plus. Plus is an adding and I keep the order. So I'm going to get the plus sign for the word plus. I'm not switching the order, and what I'm adding together to twice Mark's age is Paul's age. So for my answer to 19B might be twice Mark's age plus Paul's age. That feels good. That feels good. Eventually, we'll get to a slightly new kind of problem. You can give 21 a go. Maybe you don't even need to watch me do 22, A and B, but I'll start with this. So for 22A, I want to find the quotient of, and it's not the quotient of Z and X, it's the quotient of Z and the difference. So first, I have to find the difference. Of X and Y. And difference is just a straight subtraction, not changing any order. So difference of X and Y is just X minus Y. And now I'm going to find the quotient of Z and this difference, either using a division sign or using a fraction. If I use the division sign, I really do need the parentheses. If I use a fraction and put this X minus Y in the denominator, I don't actually need the parentheses. So multiple correct answers. So quotient means Z, the quotient of Z, which is going to be written first. The quotient of Z and the difference of X and Y can be written like that with a division sign. If you use a division sign, you need the parentheses. If you don't use the division sign and you use a fraction bar, then that parentheses is going to be implied by the fraction bar, or it's going to be made not necessary by the fraction bar. So both of these would be correct answers for 22A. On my answer key, I only have the second answer as opposed to the first. For part B, it starts off with the quotient of X, Z, and X. And the quotient of Z and X is either just Z divided by x, or it's the fraction with z in the numerator and x in the denominator. Because I don't have that extra word, since there's no operation between the variable z and the variable x, I'm not going to need a parentheses. Here, in problem 22, between the variable z and the variable x, there's another operation. That's when I know I'm going to need a parentheses. So almost done. That's the quotient part. And now I need minus, and I don't even have minus here. Gosh darn, I got awfully lazy when I was doing this. Minus is a subtraction, and I'm not changing the order. So minus is a subtraction, and I'm not flip-flopping the order, and I'm minusing y. So both of these would be correct answers for 22b. And I don't have both answers on my answers, I just have the second. Just in case you're interested in trying 21a and 21b, there's the answers I have written down for 21a and 21b. I feel like they're right, but they haven't been checked yet, so there could be some mistakes. '23 and 24 use the word per. That's a real common word to see. The key word in 23 is per. The key word in 24 is per. And the word per is just going to be a fraction, and it keeps the order. When I see 25 cookies per B boxes, I did the number 25 first, the variable for boxes second. It's just a division problem. So in 24, to 20 days per month, I can say it's 20 divided by m, because I'm using the variable m for month, or just 20 over m. So that's 1 through 24. Each one of those problems just wanted me to create an algebraic expression, which is just a problem that doesn't have an equal sign. The next few problems, I've written up a bunch of explanations, but I don't think I'm going to show what I wrote up. I explained how to do the next few problems, but I think I could explain them just by doing a problem. So problems 25, 26, 27, the next few problems have a new skill, and they're very similar in that I need to translate some words into algebra. The big difference is in each one of these next few problems, there's a word is, and is generally replaced with an equal symbol. And when a problem has an equal symbol, we call it an equation as opposed to an expression. Expressions have no equal signs, and that's what we did for problems 1 through 24. We created expressions. And none of those problems had the word is. And in the next few problems, the next 5 or 6 problems, we're going to be creating equations, and those have equal signs. For right now, it doesn't really matter whether a problem has an equal sign or not. But as we get later in the course, there's legal algebra that you can do when you have equal signs that you can't do when you don't have equal signs. So it's not a big deal now. But it's going to be a big deal to be able to identify the difference between an equation and an expression. So I'm going to try to just go straight through 26a. So 26a, preceding the word is, which is going to be my equal signs, it says Gloria score, which is my older sister's name. So for Gloria score, I'm going to put the variable g in. And then for is, I'm going to put equals. And then after the word is, I see 5 more than Anthony's score, which is one of my brother's name. I have 2 sisters and a brother. And more is an adding word, but I switch the order. So more, I automatically know I'm doing a plus sign. I'm adding 5 more than Anthony's score. I'm switching the orders. So Gloria's score age is 5 more than Anthony's. Is that even right? No, I think she's actually 4 more than him, but hardly matters. Anyway, so I just made this up. So the answer to part A is Gloria score G equals 5 more than Anthony score A plus 5. That's all there is to do. Now I've made an equation. Oh, it's not age, duh. Sorry, man. I don't know what's going on here. Anyways, part B says if Anthony scored a 90, I was looking at part 25 and thinking age when I was doing this problem, but this is just scores. So part B, it says if Anthony scores 91, what does Gloria score? What I'm going to do is I'm going to replace the variable for Anthony's score with a 91 and add 5. And I'll get Gloria's score is 96. Usually if I'm answering a word problem, I like more words than just a number. So I'm going to try to emphasize that this represents Gloria's score. So 25A and B should work similarly. For 25A, you're going to start off preceding the equal sign. You have Maya's age, which is just going to be an M. The is going to be an equal sign, and then 2 more than Etta's age. That's hardly different than 2 more than Anthony's age. You'll get an equation, and then part B asks you to plug a number in. Let's do maybe 27 together, and I'll skip on 28. So for 27, maybe pause the video and try to do it by yourself. But if you can't, it starts off with the area of a triangle. It tells me the letter to use, or the variable to use is A. Then it has the word is, which is equal. And then it says 1/2 of the product of the triangle's base and height. So I'm doing half, and what I'm doing half of is the product of the base and height. So this part is a little bit harder. So when it says half the product, I think half the, I probably should say 1/2 of the product to make sure that that multiplication is implied there, even though I don't have it written. I'll go change that. So 1/2 of the product. And now that I've fixed this problem up, there's 2 words that imply multiplication after the 1/2. Means I probably technically need a parenthesis. I need to do this product first. So for the right hand side, I need to first find the product of the base and the height. Base being small b, height being little h. Product is just multiplication with the order not changed. So this part of this, the product of the triangle's base and height is just b times h. And now I'm going to do half of this product. Technically, I probably need a parentheses. It turns out that the parentheses is not particularly necessary. That if I drop the parentheses, because those parentheses just signify more multiplication, that it's going to equal, but we haven't quite got to that part of the class to tell me that that's actually equal. So this would be a correct answer for part 27A, or just 1/2 the base times the height. And you might be familiar with that formula. So 27A, both of those are correct. The second one is probably knowing more than maybe you know right now. And part B says find the area of the triangle with base 6 inches and height 12 inches. So into my formula that I just created, area is half the base times the height, essentially is what I would say. I'm going to plug in 6 for B. Technically it's 6 inches. And I'm going to plug in 12 for h, and technically it's 12 inches. So again, maybe a little premature in terms of the algebra I'm going to try to do here. First, I'm going to do work from left to right and do half times 6, or a half of 6, which is 3. So this is going to give me the area is 3 inches times 12 inches. 3 times 12 is 36. Inches times inches are square inches, or inches with an exponent of 2. So for an answer for 27b, I'll say the area of the triangle. I'm just going to be lazy and say the area is 36 square inches. And I can write square inches like with an exponent of 2 like that. That would be square inches. Or I can write the word square inches. Or I can maybe do SQ period, IN period. Just something that attaches some words to your answer. Anytime I'm doing a word problem, I like to have words in my answers and not just numbers. So this would be nice, saying the area, maybe something a little more verbiage, maybe the area is, would be nicer than what I just about wrote. But something like that would be fine for 27. So I'm going to try to do 30, which I think is harder than 29. Maybe you can try 29. So first of all, when I go through and read problem 30, it says the stopping distance D in feet for a car is, so stopping distance D is equals, and that says twice the square of its speed. Twice, I know it's going to be 2 times, and I'm multiplying it by something new here. The square isn't something we've had yet, but it's something you might know. The square is going to be an exponent of 2. So the square of its speed, I'm multiplying twice, or 2 times, and then the square of its speed, which is going to be the speed with an exponent of 2. That exponent up there is a square. So for part A of number 30, my answer, the stopping distance in feet for a car, is twice the square of its speed. And this is kind of a make-believe formula. I mean, there's a lot going on to do with how the stopping distance for a car, the kind of brakes, the weight of the car. There's all sorts of variables that could be added to this. But this is just a generic, simple equation. So for part B of number 30, I need to find the stopping distance by plugging in, so let's find the distance when the car is doing 30 miles per hour. So I'm going to go, the stopping distance is 2 times, and I either need a times symbol or a parentheses to separate the 2 from the 30 squared. And now ugly math. 30 squared is 30 times 30. I'm going to bring the 0 down, this 0 down. I'm going to go 3 times 0 is 0, 3 times 3 is 9. So that's lazy multiplying. Anytime we have big multiplying to do in this class, and I would call that big multiplying, I'm going to let you use a calculator. I'm not, committed to wanting you to be able to do that. And then 2 times 900 is 1800. And this is going to be the stopping distance of the car in feet. And that's cruddy breaks. That's like 1/3 of a mile to go from 30 miles per hour. So it's a pretty poor formula. It is what it is. But I'm just going to write for my answer. I'm going to say the stopping distance. Gosh, if it took me 1/3 of a mile to stop from 30 miles per hour, that would be bad. But it is what it is. Alrighty, a few more, and then maybe I'll do a part 3. Let's maybe do 31 together rather than me doing 32. So maybe pause the video and try 31. If you can't get it, it's fine. So as I read through 31a, the distance an object falls in feet, d standing for distance, is equal to 5 times the square of the time that it falls. This is just like the problem I just did. I'm doing 5 times, which is multiplying 5 times some variable, and it's the square of the time that it falls. So it's going to be 5 times and then the square of the time t. For 31a, it should be distance equals 5 times t squared. And then it says for part B, how far will the object fall in 3 seconds? The units are going to be in feet. The distance that it falls is going to be 5 times 3 squared. We don't have orders of operations yet, but I need to do the squares first. We'll get to orders of operations. So the distance is going to be 5 times 3 squared, and 3 squared is 3 times 3. And 5 times 9 is 45. So it will fall. The object will fall. The number is 45, and it tells me the units are feet. So for 31b, something like that would be a good answer. Sentence would be better than not, but I don't always write sentence, but I always want units if those are applicable. I think 33 and 34 are enough alike that I could do 34 and let you try 33. 34 starts off, it says Joe's age is. So Joe is age J is, and then 5 more than Debbie's age, D. More is an adding, but you switch. So it's switching the D and the 5 on either side of the plus sign because the more is a plus. That's my answer to part A. Your answer to part A of 33 is going to be real similar because you're going to start off the length of the base of the triangle B is. Less than is going to be a minus, and you're going to switch. And then for part B of 34, how old is Joe if Debbie is 21? I'm just going to plug in 21 for Debbie's age. I'm going to get Joe's age is Debbie's age 21 plus 5. And get Joe's age is 26, and maybe I'll just say Joe is 26 years old. Oh. Alrighty. One last problem, and maybe I'll do a part 3. So you should try to do 35A and 35B. I'll scribble down answers. Mary's time M is 8 minutes less than Jenna's time. So Mary's time M is equals 8 minutes less than Jenna's time. Less than is a subtraction, and you switch the order. I'm switching the J and the 8. And then what's Mary's time if Jenna finished the race in 1 hour and 20 minutes? So that's a little bit harder because Jenna's time is 1 hour and 20 minutes. So Mary's time is going to be Jenna's time, 1 hour and 20 minutes, minus 8 minutes, and this is poorly planned last problem. I'm just going to subtract the minutes because the hour part's not going to be impacted by the subtraction. I'm just taking the 20 minutes over an hour, subtracting the 8 minutes, and Mary's time will be 1 hour and 12 minutes. Alrighty, so I'm going to pause and do a part 3.